Hello, everyone. We'll just give it a few more minutes for everyone to join, and then we will start. Welcome. I think it's time that we can start. Okay. Hello, everyone, again. Welcome to our webinar on making data agile for scalable AI. My name is Lana, and I'll be your moderator today. We're excited to have Dr. David Wainwright, our Chief Strategy Officer and Principal Consultant for Data and AI at PRODYNA, with us. This session will last for 45 minutes, so please feel free to submit your questions via chat, and we will address them during the Q&A part. It's time to get started. Dr. Wainwright, over to you.
Thanks, Dana. So welcome, everyone. Today we're doing this in English because I think we have people from different countries. Can someone just give me a quick thumbs up if you can hear me and see my screen before I start without just talking to myself?
Yes,
yep. Okay, great. Then let's get going. Okay, so first of all, what's the, I'll sort of introduce myself first. So my name is David Wainwright. I've been with the company since 2006, so an awful long time in different roles over those years. So I started as a software architect, and at the latest point in time, and I'll explain that in a couple of seconds, the topic of AI has come tremendously important, and that's really come out of the data field. But what's the reason for talking? Let's go back to the title slide. What's the reason and the motivation for talking about things today? It's really that a lot of customers are coming to us and asking, okay, yeah, we've done all these AI POCs, and we've had a lot of problems actually scaling those POCs into a real production scenario. And I'll just go through a couple of reasons in a few slides, what we've learned from doing many of those POCs, and offer a solution, or maybe a thought process that you can enter into how we can start to make our data more agile and make it work for the company. And one of the sort of emerging methodology that's coming out now is the idea of distributed data mesh. So there's really three parts to this presentation today. So what is the motivation? What have we learned from doing many AI POCs? And we're not going to talk about AI really today. We're going to talk about the data behind it. Then we're going to talk a little bit about the data mesh, the ideas and the concepts behind data mesh, and why these ideas could be useful in helping your organization make your data more agile and more usable. And then maybe the last third of the presentation, I'm going to go into talking a little bit about Microsoft Fabric and how you can maybe use Microsoft Fabric to implement a data mesh in your organization. Okay, so it's not a sales presentation today, but anyway, it's probably good to let everyone know that's here today who we are. So PRODYNA is a system integrator. We've been around for more than 20 years, and we have more than 400 consultants in the DACH region, in the UK, in Greece, and in Serbia. So we come from the software implementation field. We've been writing custom enterprise software for 20 years. So app innovation together with Microsoft is one of our very strong strongholds, together with data and AI, but also the cloud infrastructure and cloud security, because obviously in this day and age, not going to be able to do too much with data and AI without doing that in the cloud. So our world before November 22 was bifurcated. So as I just said, we come out of the software development corner. So app development, app innovation world was very much separated from our data and AI world. So we had part of the company doing application development. We had part of the company doing data engineering and data science projects. But it was fairly uncommon that applications would really use a lot of data and applications. Okay, transactional data, but other types of data was a fairly rare case. And then November 22, with the advent of the hype starting around ChatGPT, and obviously together with the other cloud AI services and machine learning, things have been around for a long time, not necessarily starting at November 22, but with the advent of ChatGPT, what we saw was the merging of these two fields and the ability with the large language models to create a lot of new use cases, a lot of these in the customer experience field that require an awful lot more data. So for us as a system integrator, the large language models have really brought these two parts of our portfolio together. And this is also what we're also seeing on the customer side. And in 2023, the year following ChatGPT, we had almost 40 AI use cases. And we saw a lot of problems turning up here. So one of the problems was obviously, it was many cases, it was difficult to find business value, but that's a discussion for another day. What we definitely saw was that a lot of companies had a siloing of data. They weren't able to provide data, or the organization wasn't able to provide data for these AI use cases. Quite often they were only able to provide synthetic data sets, and a synthetic data set is definitely not or in many cases not comparable to what we actually the real life scenario. It's easy to create a synthetic data set or some sort of extract, but when it comes to actually taking your POC and scaling that up into a full scale, maybe even critical application, then all of these aspects such as data relevance, data continuity, data quality, they all play a very and the integration of backend systems, right, and security across backend systems, they all play a very important role in making an enterprise grade application. And a lot of these things aren't really looked at in a POC. A POC takes a use case, a simple small amount of data, and says, okay, yeah, it's theoretically possible. But the buts come a little bit later. So we definitely saw siloing of data, or the inability to provide good quality data to an application team. And the other thing we saw was the siloing of experience, how to use data within the company. So let's look at these two failure cases or failure scenarios. Look at how we can maybe use the data mesh to get around these failure scenarios. But before we go into that, I'd like to clear out one say misunderstanding that we still see even a couple of years into the Gen AI thing. This misconception. It's mainly on the customer side, but let's take a bot in the consumer world and think of questions. And you might want to just maybe even ask ChatGPT, can you generate me a picture? Or who was the US president in a particular year? Or maybe you're going on holiday and want to know what's the best places to visit? Or the classical one that started with ChatGPT, write me a poem about something. But the expectation is that the bot knows the answer or has all of the data, and the bot can immediately say, sure, here's your answer. And that's kind of different in the enterprise world. So here in the enterprise world, we need to do something different. We're talking about Gen AI. So we need to find some data, some documents somewhere. For example, the documents might be something else, but let's take, for example, a couple of documents that exist somewhere in your organization. Give these documents to the bot and then ask the bot a question. So we need to have the data. We need to be able to provide the data to the bot. We're not expecting a bot such as, or a large language model such as ChatGPT or one of the other ones to know all of your secrets. It's good that it doesn't know all of the secrets. And then we're going to ask this bot some question about your own data. So I just want to clarify the issue for anyone that might be here in the webinar today that hasn't quite realized that in the enterprise world we need to have the data, and we're going to give the data to the bot and get the bot to generate something. We're talking about generative AI here in the most cases, and we're going to use the strengths of the generative AI, the language strengths of the generative AI, to interpret the data that we've given it, and give us a reasonable answer that we can give back to the person that's asking the question. So the first problem that we saw, the biggest problem by far, what we see in companies that want to get started with AI, is data siloing. So immediately we have three problems, and I guess everyone here probably knows what data siloing is. This means that we have different systems, IT systems within the organization, such as CRM or an ERP, or maybe you're a manufacturing company and your engineering teams have stored their data somewhere else, and probably your legal team stores data somewhere else. We immediately have three problems. Firstly is the accessibility. Almost no one in the organization has access to all of these different data silos. And if you did, all the data in these individual silos is in completely different formats. So it's technically incompatible. And then we have a further problem. It's the data in each of these silos is probably semantically incompatible. That means that the business interpretation of different values within the data is completely different. So we have three huge problems. And the effort required to get data out of these data silos, bring it into a common format, is for the most organizations an almost impossible task, unless we go about it in some structured kind of manner. And just to show you what we're missing out on, just take, for example, it's an information bot. And let's take for our example, let's pretend that we're in a construction scenario and we're trying to build a big sport arena in Berlin that we just call the Spree Arena Berlin. So we've almost certainly got different personas, such as engineers or project management or marketing, them or the project renderings. Or we might have the customer, right? That we're building this sport arena for, and they're asking all the time for different pieces of information. Can you give me the latest version of the floor plan? Or maybe even complex questions. For example, if we would like to swap the normal glass that is planned for UV protected glass, what kind of delay can we expect? So that sounds easy, but in the set of data that we have, we might not have the direct answer to this question. How long would the delay be? So we have to go and look for individual pieces of data, and then we have to, maybe make some calculations to come up with some sort of reasonable answer. So you can start to see that the complexity here, we're not just talking about a really simple bot, who's the president of the USA, or we can directly find an immediate answer somewhere out there. We're going to have to search around for different pieces of information, put them together, so generate context, maybe do some calculations, and then come up with a reasonable answer. But if our data is siloed, we're going to need data from different parts, different silos, then we're only going to get a few bits of information. We're not going to get even find most of the information that we need to create these calculations, because they're stuck in some silo, completely disjointed and incompatible with one another. So what we really need is connected data. That's what we see here on the left side. We need data with context. And on the right-hand side, we just see maybe a technical representation of structured data. So here we have a representation of a project with a status, with different pieces of metadata, such as the name, attachments that we might store data within, and links to other information that we can put together to create context. So if we want to ask questions, or if our customers or our project team or anyone wants to ask questions about the project that we're conducting here, construction project, that we can put the data together and create answers with data that has context. So these that we can say, okay, it's not any version of the project plan that we're giving back to the customer or using to answer questions. It's the latest version, or the latest version of the project plan that we're using to answer questions. Okay, so the point here is, we need connected data, and who, if anyone, in your organization actually connects these dots? Because this connected data, it doesn't connect itself in many cases. Usually, the people that connect the data are someone from the data team. So most organizations, or a lot of organizations, are organized centrally, and they have some sort of central data team. And the central data team usually has this big white box here in the middle, some sort of big data platform. There are many of those on the market. There are legacy big data platforms. There are more modern cloud-based big data platforms. But in any case, they generally work in more or less the same fashion. So on the left-hand side, we have many, many data sources, and we ingest this data from all around the organization, and sometimes from outside the organization. The data team then works on this data and produces new data sets that satisfy customer needs. But we have this central big data platform, and that's not the worst thing. Let's just go in and have a look how these people actually work. So we have this ingest phase, where data engineers create ETL pipelines to ingest data from all of these internal and external sources that might be there. Then we have other data engineers or data scientists that actually process the data, get rid of the rubbish, try to find business value within the data, and create new data sets that are then served to your consumers. So we have a couple of problems here immediately. So we see a process here from left to right. On the left-hand side, the number of data sources is continually increasing. And then we have on the right-hand side, maybe on the consumer side, that the innovation agenda, or the number of use cases that the company actually wants to implement, or that the management of the company wants to implement, is increasing rapidly. And this puts a huge stress on the number of sources, right? So the amount of work that the data team needs to complete is increasing almost exponentially. In particular, with all of these AI use cases, and that this workflow from left to right, So one person doing ETL pipelines, maybe other data scientists doing the processing of data, creation of new data sets, and making them available to the consumers. This is a linear process. And this is what causes a lot of the delay and stress within a centralized centralized data team with their own big data platform. Because any change that comes, even in an existing data set, means that all of these people have something to do. Right? So either a new data set or a small change, then all of these people have to communicate with each other. They have to understand what the requirement is, and then they have to do their job, and then communicate to the next person. Okay, they've done their job, and then communicate to the people, to the consumers out there. Okay, we've updated the data set. So this is obviously not very scalable, and this is not even the worst part. The communication barriers within the communication problems don't stop with the data team. We have to the left, we have cross-functional teams that are creating data in the organization. And on the right-hand side, we have cross-functional teams that want to consume the data. And these teams have been in most organizations, the last couple of years, they've been spending becoming agile. So we have agile software developmental projects. We've seen the convergence of IT and the business in many organizations to build cross-functional teams. But somehow we've forgotten the data people. So A lot of the business teams have become agile. Software development has become agile, but in most cases, the data team is still working in the same processes they worked in 10 or 15 years ago. So we have communication barriers between the people producing data. We have communication barriers in the people that are between the people that are consuming the data and the big data team or the data team. And to make things worse, the data team doesn't generally have any idea or any good business understanding of what this data actually is. Yeah, so all of the business knowledge, yeah, is to the left and to the right. But the people that actually have the skills to manipulate data and to theoretically find business value in the data are the ones that don't really have any business understanding. Yeah, so we have a complete separation of of tasks and understanding. So that's the second problem, the siloed knowledge, right? So we had the first problem was a data silo, so we wouldn't have access to the data. And the second problem that we've seen in all of these AI PoCs that we did last year was the siloing of knowledge and the inability of project teams or business teams really to do very much with data themselves. So the hypothesis here for this webinar is really, okay, is the distributed data mesh, or data mesh, people usually say, could this be a solution for these two failure modes that I've just presented? So first of all, what is it? Is data mesh an architecture? Is it a list of principles? Is it an operating model? It's kind of a mix of all of these things. It definitely has a change management aspect to it. It also has a technical part to the implementation. And I think that, or I firmly believe that every organization that seriously considers implementing a data mesh will probably do this in a different way. It's a little bit like Scrum. Yeah? So every organization that implements agile processes implements them with their own flavor according to how the business is structured, how data affine, or how technologically affine their employees are. So data mesh is described as a decentralized socio-technical approach to access and manage analytical data. If I can put that together and just describe it in one sentence, it's a set of principles to make data more agile within the organization. Yeah, it's more focused on analytical data, but not exclusively. And these 4 principles, we'll look at these in detail, are the foundation of the data mesh. Probably they're all important. I was going to say probably the most important, but certainly the biggest one to understand is the idea of domain ownership. Yeah, we'll go into that in detail. Then we have data as a product. So we want to move away from thinking about data as something we store away in a database and keep for another day and don't use. Yeah, we've probably most of us have understood, okay, data is important, but not a lot of us have understood how to actually use the data or make it available to other people that they can use the data to extract business value. Then we're going to talk about self-service data platforms and moving away from a centralized monolithic data platform to easy to use self-service data platform. And we're going to talk about federated computational governance. And the reason for that will also become clear. But let's go into the first principle. So what you see here on this slide is another big white box. But instead of this big white box being your central monolithic data platform, this is your business. So, and any business can be split into different domains. So different parts of the different parts of the organization. And some parts of the organization are representing the facts and the reality of the business and generating data. Yeah. And, for example, parts of the company that produce products. Yeah. And we have other parts of the organization that are more consuming data, for example, marketing. They want to know which of your products is being sold, for example, what consumers really want. So we have parts of the company that are more producing data and other parts of the company that are more consuming data. But the important part of the thing is that we're going to get rid of the idea of a central data ownership and give the responsibility and the ownership of the data back to the domains. Yeah, so we're going to move from this picture to the next slide, and we're going to see that not only the data ownership, but also the responsibility for manipulating the data moves from a centralized data team or data organization to each of these domains. And just like we've just similar to how we've done that with the business and the software developmental processes, we're going to move also the skills for manipulating data and analyzing data from the central data team back to the domains, because the business understanding, what are we actually doing, what type of data are we producing, and what is the real information in that data belongs to the domain. So we're going to make the domains the first class citizen and get rid of this idea of centralized data ownership. So each of these domains is now going to be serviced by a cross-functional team. In most cases, we've already had a cross-functional team, the business and the software development, but now we're going to move these roles such as data engineer, maybe domain product data owner role, maybe an AI engineer. We're going to move these into the domain. So what are the benefits of actually doing this? It gives us the ability to scale, right? So a centralized data team is obviously not scalable, right? They're just exploding with the amount of requests that they get, right? With this domain idea, we can scale the size of the team, or we can scale the number of the teams that we have. So, and here with this type of organization, we can go with an increased number of data sources, and we're also optimized for change, because everything that changes is within this domain, right? So we don't have the communication overheads with having to speak to other parts of the organization. We can handle change within the domain, and we can also make sure that we don't lose our data truthfulness, because the business understanding of the data that we're producing or consuming, the business understanding, is also here. If you let a centralized data team work with your data, and when they have obviously no business knowledge of the data, then the chance that they misunderstand or misinterpret things that they might find in the data is quite high. About moving the responsibility back to the domain means that the people that have the business understanding for the data are actually the people that are working with the data. And we can enhance their agility, because we can work within our domain. We can set our own priorities. We don't have to respond to everyone to what other domains are doing. We can do everything within the domain. So that's the idea of the domain ownership. We're pushing the responsibility for the data to the domains, and also the responsibility for working with the data. And that leads into the second of these principles, that is data as a product. So what we want to do here is, let's put it a different way. What we want as the entire business is to get more value out of the data, right? And we want to move away from just saving data and thinking of an asset, but rather thinking about it as a product. If I'm a domain, then if I'm responsible for the data within my domain, that I want to be able to distribute my data to other parts of the organization. And if I want to distribute something, then I need to be able to package it somewhere. I don't want to save it away in a database where no one has access and no one understands it. I start have to thinking about, okay, how am I going to make my data or my data sets discoverable? How am I going to make them usable or addressable from other people? They need to be trustworthy. If I want other parts of the organization to use my data, then my data has to have a certain quality, and other people need to be sure that when they start using my data sets, that they can rely on the data, that it's correct, that it's timely, that the data is being updated at regular intervals, and so on and so on. So it needs to be self-describing. What does this data actually mean? And obviously topics such as security are important. But another point here that's really important is that each of these data products is autonomous, right? So the domain is responsible for their data products, and they can do that as they wish. They can do that completely by themselves. So all of the business know-how and the technical know-how is within the domain itself. And we really want to drive a data-driven culture, yeah, and with the goal of getting value out of the data. And this is really the idea of creating these data products that others can use. And we'll come back to that in a second. So we started off with breaking up responsibility into the domains. The second principle, data as a product. And now the third is some sort of shared self-service data platform. Because we've got rid of the centralistic team now. We're trying to get rid of. So the goal is we want to get rid of the central data platform, this monolithic thing that's really hard to use and only hyper-specialized technical people can actually use it. What we really want is a self-service data platform that everyone can use, that's really easy to use, and that has the features there to create data sets, data products, and be able to make those data products available to other business domains within the organization. They can use it. So the principle 3 is really the shared self-service data platform. And we can use our infrastructure team to provide, to make the data platform available to everyone in the organization. But really critical here is that there's no central data team responsible for operating the data platform. Yeah? This is a piece of infrastructure. And what we want to do, and the motivation for doing this, is we want to abstract the complexity away. We want everyone to be able to use such a data platform. We don't want them to have to do trainings or study technical manuals or do an SQL course or these types of things before they can start, playing around with data. This is abstracting away the complexity, easy to use, reducing the cognitive load. And we want to mobilize the developers, even the software developers that previously may not have been able to use a highly technical data platform, but to get them using this easy to use self-service data platform. And what we also need to do is to automate governance, right? So data governance, really important topic. It's probably out of scope. This topic of data governance sounds pretty out of scope for this presentation, but we're certainly going to need data governance within the data mesh. But now we kind of split up the responsibility into different domains, and we now have different domains producing data products. So we're definitely going to need a governance, and we need this to make this governance as lightweight and automated as possible. And that's the fourth principle, this federated computational governance. So we want to use the features of modern cloud platforms to take away as much of the people work as possible. So we want to use policies as much as possible. We want to automate as much as possible. But we're still going to need representatives from each of these domain teams. This is why it's called federated, to agree on certain things, because we're creating data products. So we need to make sure that these data products are compatible with each other. So we don't want to go the wrong way by making everything incompatible with each other. Otherwise, we would just take that data silo problem that we're talking about at the beginning and make it worse. Right? We're going to make sure that the data products that we create are compatible. At the same time, we want to automate as much as possible to reduce the communication overhead. It's the communication overhead, or when we need to communicate, it always costs time. And there's always the possibility that miscommunication or misunderstanding can creep in there. And modern cloud platforms and cloud-based data platforms provide the functionality that we need for federated governance, and all of the computational and parts of that, using policies to make sure that everyone adheres to particular guidelines. So let's look at how this data mesh model works in operations. We have our business domains, and each of our business domains has cross-functional teams. So they have the skills to use a self-service data platform. So they can start using this without too much training. They can use the self-service data platform to create data products, and they can share these data products with each other. And obviously, these data products need to adhere to global policies, that are created by this federated computational governance, which is then staffed by these domain representatives. So we're really looking at moving the effort away from a central team to the cross-functional teams, getting these cross-functional teams working with data, with this easy-to-use self-service data platform, getting them to use that self-service data platform to create data products, that can then be shared within the organization, right? And when we get this sharing working, get other teams using our data, maybe then building on that data, I'll come. It's the second, well, the last part of this presentation is how these data products really start making the business, or making our data agile, because we need these data products to be able to share data, and sharing data starts to make us agile. But how that works is now the third part of this presentation. But okay, so that's the theory behind data mesh. So what would be one way of making this theory practical, moving away from theory and trying to implement data mesh? So definitely one possibility is using Microsoft Fabric. So Microsoft Fabric is a SaaS, so system as a service data platform from Microsoft. Microsoft Fabric includes all of the tooling that we need to create a data. That's not quite correct. Microsoft Fabric, together with Purview, will give us all of the tooling that we need to create a data mesh. So we have in the data factory the tooling we need for creating pipelining on all of our ETL processes. Then we have with data engineering, data science, data warehousing, and real-time analytics, all of the tools that we need to store and analyze data. And with Power BI, obviously, the visualization of data. With Data Activator, we have, let's call it a business rule toolkit that can act on, let's say, particular events when a value within some data warehouse or some part of our data universe exceeds a particular value, then do something. For example, send a mail or alert someone. So the data activator is kind of a business rules engine that can act on all of the data, all the values that are here within Microsoft Fabric. And all of these tools sit on one lake, which is a unified data storage platform that exists on a tenant level or an organizational level. So all of the artifacts that we create, data lakes, data warehouses, and many other things, such as notebooks, they're all stored here in our sorry, the notebooks aren't, but all of the data is stored here in one lake, and we have a universal store for our data. And Microsoft Fabric is obviously sits on top of all of the other functionality that Microsoft then delivers in its particular cloud, diverse cloud products, M365 or the Azure cloud. So we have the possibility to use all this functionality in conjunction with M365 and the Azure cloud. So Microsoft Fabric has a particular point on being easy to use. So we have persona optimized experiences. We have the complete interface for data analysts. We have the complete interface for data engineers, a different set of tooling for data scientists, and so on and so on. So it's designed with a particular focus on being particularly able to be easy to use. In many cases, it's no code or low code, so it's also usable by people with less technical ability. But on the other end of the spectrum, if you're a data scientist, you can do all of your data experiments and create all of your notebooks with Python code, as you've been doing maybe up until now using Azure Synapse. So this tool caters to beginners and also to the technical users, and with persona optimized experience. It's completely browser based. So that's the tool. How can we actually use this tool to implement this tool within our organization to really start creating a data mesh within the organization? So what we have here is a theoretical business architecture. It's for a logistics company, but doesn't really matter. So we have, within any organization, we're certainly going to have different business areas. Here, these arrows here on the left, and these business areas are certainly going to have different business domains that have particular jobs to do, focus and particular jobs to do. So let's take two of these business domains as an example. Doesn't matter which ones they are. Here we have supply chain planning and purchase order management, and look at how we can build up a data mesh, or how we can share data using Microsoft Fabric and the data mesh principles. Yeah. And that's what we see here on the next slide. So we have the business architecture on the left, and we have these two domains. Yeah? The box here is the domain context, and each of these domains has an application domain. That's a set of applications that is used by that business domain. We then have the domain model, which is a description or a semantic description of what the domain is, and then we have the data estate of the domain. Might be transactional databases, might be something else, and of course, obviously, very importantly, these square boxes here right down the bottom are the other data products, and these are the interfaces or the things that we use to communicate from domain to domain. Right. So let's go to the next slide. This shows here again our application domain. Maybe in Azure with transactional databases, might also be in 365. It's not a problem. Yeah. And on the right-hand side, we're now going to have our data domain in Fabric, and these square boxes again are our data products. So subdomains are also no problem. Yeah, our data domain can be broken down into subdomains if we have particularly complex domains, or if you have particularly complex domains within your organization. And to build this is really easy in Microsoft Fabric. So it's completely browser-based. Yeah, we can just simply go to Microsoft Fabric in the settings and say, okay, let's create a new domain, supply chain planning. We can add people that are responsible for this. Probably better not to do it here. We can do that later in a better way. And then we can, within the domain supply chain planning, we can create a new subdomain, for example, demand management. Just with completely doing this here in the browser. And we see here, it's very, very easy to create these domains and subdomains. And once we have these, we can simply click on a subdomain, and we have, for example, here the supply chain management. This is now our workspace. We can now immediately start to do things such as creating lakehouses or creating notebooks and actually starting to do work. So we now have, let's just go back a couple of slides. Yeah. So we now have our domains and subdomains, and we want to start using Microsoft Fabric to actually start doing work and to creating data sets and sharing data sets. So that needs to be compatible with our organization, and we're always obviously going to need some sort of control within Microsoft Fabric. So here we have a very high level architecture diagram. So the gray box here is the tenant level or platform level control level of the entire Microsoft Fabric. And within Fabric, then we have our domains. They're the business domains that we've been talking about. And each of these business domains can have multiple workspaces, right? And all of the data that we have here are organized, organizationally organized into the domains and their workspaces, and then it's stored in OneLake, which is basically the data store for all of our domains and obviously then all of the workspaces that these domains have. So we have domain level control, we have the workspace level control, we have item level control, and we have control all the way down to particularly object levels. For example, we might want to create some sort of tables that we make available to someone. And each of these levels have different roles, such as admin or member, contributor, viewer. Not all of these levels have all of these roles, but I guess you kind of get the idea. Yeah. So we have granular control over Microsoft Fabric, and we're going to need a mapping between these roles and people within the cross-functional team. So here we have our cross-functional team with the example supply chain planning. So we have, within this team, we have people such as the business owner or the application owner or the data owner and people that are doing the work. Yeah. Software engineer, we don't have that person, but people like data engineers or data scientists. And we're going to need some sort of mapping between all of these roles. So it's got a notification on my screen, get rid of that. We need a mapping between these roles and the fabric roles. So there's a couple of super level roles, such as the fabric administrator. This is probably want to delegate that to the global IT admin. And then we have a control, for example, on the level of the domain. We have a domain administrator. That might be your business owner, or it might be a DevOps engineer. And then we're going to have people that contribute to the domain. Remember that your business domain is probably going to have multiple workspaces. Yeah. And on the workspace level, we have 4 different roles: administrator, members, contributor, and viewer. Probably the most important of these roles is the contributor role, because here are most of the people doing the work, such as data engineers and data scientists. So you might have a machine ML ops engineer. These are the ones that are actually working with the data, and they're working with data within a workspace, right? And they're going to do their work within their workspace, and they might want to share the data or share the data sets that they create there with other people, such as business owners, or with the actual data analysts, the people that want to use that data to look for something within that data set. So we can very easily map the different fabric roles to people within the cross-functional team. We should also do that with not on a one-to-one named person, but on an entity level, with using the Active Directory, or Entra ID as it's now called, and also Microsoft Purview, data governance tools. So we can combine Fabric very nicely with Microsoft Purview. So what we actually want to get to, the point we want to get to actually make data agile, is represented by this slide. So here we really see 2 business domains: supply chain manager, supply chain planning, and the purchase order management. Each of these has their own applications. They're generating data and they're integrating data, using Microsoft Fabric to create their own data products, right? And this domain can use their data products then to do their own analysis with Power BI, or to create some sort of AI use cases on top of their own data products. But then they're making this data product available. So the domain supply chain planning is making their data product available to other domains, such as purchase order management, that they can then integrate their data into and make their own data products, using the data, or using parts of their data produced by another organizational domain. So that we're starting to see data being shared, business value being extracted out of that shared data by another domain, and so the whole sharing process goes on. The data product produced by purchase order management can then be used by a further domain, and it can go the same cycle again. So seeing value being extracted from the data, we're seeing autonomy within the domain teams, right? So the supply chain team can do what they like. Okay, they're producing a data product, but they're also compliant with the computational governance. So the other teams can see what's going on here, right? And all changes are within this domain. And we're also seeing decoupling between the teams. So just because one team, maybe for whatever reasons, they are going slowly or not progressing very well, it doesn't slow down any other teams. They're completely independent from one another. So everyone's producing data and sharing data, and we've got rid of this data siloing problem to at least to a certain extent, and we've got rid of this siloing of knowledge within a centralized data team. So this is the idea behind using distributed data mesh and using a product such as Microsoft Fabric to make the data agile. And when we have agile data, then we can really start to do all of these AI, or implement all of these AI use cases that we've been now talking about for the last 2 years in a scalable manner, and actually take them into production without having them fail, or not even being able to really get them properly implemented because of problems with the data. So just to finish up, a last slide to show you how these 4 principles of data mesh and Fabric and Purview play together. We have this domain-oriented ownership, that empowers the domain teams so they can now use the self-service data platform. It should prevent data siloing. Yeah, we're now producing data products that can then be shared within the teams. And we have our federated computational governance to make sure that these products are well described, that they adhere to a certain data quality mandate, and that they can actually be used by other domains within the organization. So this is how all of these different products and the principles then fit together to make data agile. From what we've seen in the last year and a half now, with creating many AI PoCs, many different organizations, particularly within Germany, this would be a great help, and this would certainly help and accelerate the use of AI within your companies, and also the ability to use AI to generate business value, which is, at least up until now, been a very big stumbling point in getting making this AI really work for your organization. And from what, again, just to reiterate, from what we're seeing, the most problems and the thing that inhibits business value generation with AI is really data problems. And data mesh could be an answer for your organization. It's not suitable for everyone. Just to finish up with the last couple of points, for very small organizations, then these ideas are too big. For organizations that are not very technical in any way, this approach might be a little bit too technical. But it's a set of principles and ideas. I think they fit together, and it's a new idea. I mean, data mesh has only been around since 2022. I'm not aware of an organization that has a data mesh throughout the whole of their organization, but there are certainly many companies out there starting to implement data mesh, and the feedback has been positive up until now. So thanks for participating today. I hope I gave you something to think about, particularly if you have a problem with data agility within your organization. Data mesh could well be an answer. And certainly the way you implement data mesh will be probably specific to your company. There's no fixed rules about exactly how this needs to be implemented. It's a set of principles, and it's up to you to implement those in a way that fit to your organization. And certainly PRODYNA can help you with that. So thanks, everyone. If there's any questions, I'm more than happy to take questions in the chat. So with this.
Thank you, David, for the insightful presentation. For now, I don't see any questions, but let's give it a minute or so to see if anyone would like to ask something. We don't have any questions. So
if someone has any questions later, they can certainly contact us per mail.
Exactly. So we hope that you found the webinar both informative and inspiring. If you do have any further questions, as David said, feel free to reach us out at PRODYNA. And you will also receive an email with our upcoming webinars, so please stay tuned. Thank you once again for joining us today, and we wish you a great day. Thank you.
Thanks, everyone. Goodbye.
Thank you. Bye.
Bye.